Hey guys, it's Bill from Linden, Tennessee. I have a lot to cover today because I've been pretty busy over the weekend and I'm sure I'm going to forget some of it. So I have actually written a list. So I'll be referring to my list every once in a while. I can't remember if I've ever brought this up again, but I have decided that I'm going to put a front mower on Mona here. The mower that I'm using at the moment, I will put a little screenshot up right here, is a little 48-inch mower deck off of a Cub Cadet. It's off of one of the Cubs that I used to make Artie with, the 4x4 Cub. And that's what I've been using for about 7 years, and it's worked great. It's been absolutely flawless. It's just kind of awkward because backing up is a pain in the butt, and it's hard to get underneath stuff. And I don't know. I like to have new projects. So I'm going to make a front mower for this and see how that works. And what I've done is I got a guy at work. He had a couple old lawnmowers sitting in his yard that he didn't want anymore. So I got a really good deal on them, free, and brought them home. And one of them was a Yard Man, 46-inch, and the other was a Yard something or other, Yard King, maybe, I don't know. But here's a couple quick videos of Artie dragging them into the garage. That'll work. Yeah, so that worked out really good. That boom pole is fantastic, and Artie is he's just a beast. So the first one that came in that series of videos is the not Yard King. It's the other one, and it's a 44-inch deck, and I don't like it. It has two blades, and it's just really narrow, and I don't want that. I wanted a wider one. The Yard Man is the second one in that video that I pulled in forward. That's got a 46-inch deck, and that's the one I'm going to use. And here it is, all clean. Now, how did it get all clean? Let's go take a look. This is the 46-inch deck. This is the one I think I'm going to go with. I'll talk about it a little bit more for the time being. It's really dirty, so we need to do something about that. And I think I know just the critter to do it. Let's see how he do. And once again, Artie saves the day. Okay, here's where a lot of stuff starts to happen. This is a 48-inch deck, 3 spindles. I was thinking, and here, I'm going to make this all electric. Of course, it's going to be electric, but this is going to be electric with individual electric motors. These are little 900-watt Husqvarna motors. These came off of their little 21 or 22-inch push mower. 900 watts is about a 1.5 horsepower, and going to have 3 of them. I made up a little coupler. I kind of went back and forth with how I'm going to do this. I had originally thought perhaps that if I had a spindle I had a spindle in here that I could make a coupler that goes from that to that spindle, and would basically sit and do something like that. And then all the motor is doing is just transferring torque through the original spindle shaft down to the blades. And all the side loads or whatever that the blade would encounter would just go into that spindle bearings and save the motor. But I don't like how that looks. It's really tall and looks stupid. And I end up having to have some standoffs, some standoffs that come straight down and hold the motor to it just looks ridiculous. And imagine that, having 3 of those. It just looks really stupid. That looks really cool. Now, these motors are designed to direct drive a blade. Now, it is a small blade. It's behind a push mower, so you're not going really fast. But the point is that they got some bearings in there, and they should be fairly stout. But so what I'm going to do is I'm going to make a little coupler that goes on the bottom of this, and it kind of looks like this. It'll either be aluminum or metal, and it'll slide over that shaft. Ideally, it'll have a 2 flats on it, and it'll fit on there tight. Otherwise, it'll have this correct bore, and it'll fit on there tight, so there's no play. And then it'll just have 2 big set screw, maybe 1/2-inch set screws on the side that'll hold it tight. And then it'll have a relief up here so that a blade can fit on top of it like such. And then this is not the right screw, but imagine a screw that's big enough. It will go all the way through the middle of that, all the way down, and pull in tight on the motor shaft. So that'll hold everything all nice and tight together, and everything should be able to spin nice and freely. And if I decide that I want to, what I could do is I could take my little coupler here and turn it down to an appropriate dimension so that a bearing of some sort of ball bearing or needle bearings or whatever kind of bearing, roller bearing, could fit. The idea of that bearing could slide over the top of that, and I could make a housing that holds the OD of that bearing, and then that housing bolts to the same mounting positions as that the motor has. And that would control all the side load of the blades. And I probably will do that because I don't think that'll be a terribly difficult thing to do. And so that's how that's going to work. And then put this back where it goes. Like that. Like that, right there. And then the 3 of these will come to 3 of these. This is a motor controller. This is what's called a brushless DC or a permanent magnet AC. If you get like a DeWalt drill, they always like to brag about how they're brushless. Well, that's what it is. It's a brushless motor. It is an alternating current. It's an AC. It's a 3-phase motor, just like a motor you'd have on a lathe or something like that. So it's a 3-phase motor, but this has permanent magnets in it, which gives it a little bit more startup torque for a smaller size. And yeah, that's all that is. And this is a brushless DC motor controller. Now you could use this motor or these controllers are usually used for bicycles or little off-road motorcycles or whatever. So I'm going to have 3 of those, each one in control of each one of those motors. There are a bunch of wires on here, and I don't have any experience with this at all. But the way I understand it is there's 2 wires in here somewhere. That's those 2 white wires right there. If you put power on this thing, put the 3 phases onto the motor, which is what those are. That's power there. That's the 3 phases there. And if you put all that together and then have those 2 white wires touch together, this thing goes into like a diagnostic figure it out mode, and it figures out how to make that work. Now the question then is, how do I move this thing around the yard? And I'll talk to you about a couple of ideas that I had. I went to a neighbor's house, and they've got a Kubota that has a front-mounted. It's kind of like a 0-turn, but the deck is out in front of the big drive motors, and it has some little swivelly motors in back. And I had to look at how their mower deck raises and lowers, and theirs is kind of simple actually. Let me get my chair over here because my leg's starting to hurt. Theirs is kind of simple, actually. They have a swing arm that goes back. If you're familiar with my other videos, you saw how I did the tiller. It's just a swing arm that goes back, and then they've got an arm up here that pushes on some front, or pushes down some front swivel casters. So the swivel casters push down, which obviously raises the deck up, and then whenever you push that arm there, it's attached to a shaft that goes all the way across, and that shaft is welded to the pivot arms there. So whenever you pull this back, you can imagine that it's actually pulling the whole thing up. So it's pulling the back of the deck up, and then whenever you do that, it pushes the casters down, and it makes the whole thing raise up. And the way why that's kind of cool is it's very simple, of course, but what I don't like about it is if you hit a bump sideways, you can't just lift up one side. You can't just lift up one side without the other side going up. The whole thing lifts up because that bar that goes across that's welded to the swing arms, that keeps it all rigid. And if you hit the front of something, then the whole thing pivots up. It pivots up on the back swing arm points. So if the front comes up, the back kind of comes up too. And I don't know if that'll actually make any difference. I mean, Kubota has been making mowers like that forever, and I don't know if anybody's complained, but I'm guessing it probably is just fine. It's not that big of a deal. The other situation, so before I get to the other situation, so I'm not going to do it that way. What I want to do, what I thought I want to do, is kind of like a 4-bar situation. Now, a 4-bar link, you'd have to maybe look into rear suspension for like a car, for like a drag race car that has a live axle. You basically have 2 bars that go back. They'll pivot right here, and then they'll pivot right there. And then what happens is if you pick it up here, both of the bars make kind of like a parallelogram, and it makes the deck move square. And that would be cool for raising and lowering the deck. But the problem with that is, now it will tilt this way. That linkage allows it to tilt this way. But what it doesn't allow it to do is if I come up to if I'm driving along and then there's like a hill, like a hill that comes up, then the front anti-scalp wheels would hit that hill, and that would cause the entire deck to raise up off the ground. Would that be a big deal? I don't know. Maybe, maybe not. I may investigate that to see how it works. Because if that doesn't work, then the lower arms, which were there anyway, I just keep those on there. And what I'll do is I can put some swivel casters up in front, and then have the swivel casters on the top and the bottom of where it pivots. I've actually got one. I've got a demonstration here. This was, so this would be my swivel casters out here in front. And then what you do is have a longer shaft there, but you can put spacers on the bottom or on the top, and that raises or lowers the wheels with respect to the deck. So if I raise the back of the deck up, then I got to change the spacers in the front, and that'll raise the front of the deck up. And then there wouldn't be anything holding it from doing like this. Now, if you've ever seen an Electrac, that's a 1970s GE made an electric lawnmower. What they did is they just had 2 little push arms, kind of like what I've got going on here, and a belt going into a winch that would raise it for travel, but then would lower it, and then it would sit and ride on the rear anti-scalp wheels and front swivels. So that's kind of what I'm thinking about doing. That's what I will do if the 4-bar thing doesn't work. And yeah, and I've already started doing that. I had to make this big jog up here because this front axle pivots, and then there's also that steering linkage. So if this axle is all the way up going over a bump or something, and this wheel happens to be steered in one way or the other, that jog has to be there to clear all that. Now the reality is that if this wheel is going up over a bump, the deck has already done that, so it's already higher. But if there's like, I don't know under what circumstance that the deck would be at, say, the ground level, and then the wheel would go up high, and then I would also be turning. I don't know that that would ever happen, but in that rare eventuality, I'm going to build that in so that nothing crashes. And then the other side is not as extreme as this. It's just basically one bend. And then I've got a little plate. That's this plate right here. I'm going to mount that plate to the front of this with just like four 3/8 inch bolts. And then I'll weld my my upper 4-bar pivot point, or my forward 4-bar pivot point, and it'll go from roughly where my finger is down to that one. And there'll be one over on that side too. One of the things to consider when doing a 4-bar is there's nothing to keep this range of motion from happening, left and right from happening. And the way they do it in motorsports, and the way that I'll do it also, is by using a track bar. And basically what would happen is I'd have on the back of the deck, I'd have some sort of a mount, and then there'd be a bar that goes from that corner over there all the way up to, like, say, that lower corner of the frame right down there. It would just have a little bar that hangs down, and that locates the deck going left and right from moving around. But it doesn't prevent it from swiveling or tilting up or anything like that. So I will end up having to do that no matter what I do. If I do the 4-bar, or if the 4-bar fails and I have to copy what GE did with their Electracs. So one of the other situations is that if you imagine I have the 4-bar and this thing is completely suspended, there's nothing to prevent it from doing one of these numbers. And I haven't quite worked out how I'm going to keep that from happening. One thing that I could do is I could have some posts that come out from that plate right there. I could have some posts that come out straight, and then just have a chain hanging down, and then that would limit, or that would keep the deck from just wallowing around haphazardly. That would move if it hit a bump, but it would ultimately rest flat on those links sticking out from the bars. And that's probably what I'd end up having to do. So those are the two options I have. Something that I would like to do, and what GE does, oh yeah, there's a situation that occurs though. If you use these little Heim joints on the top and the bottom, you end up with a deal where there's nothing to hold on to this. It just moves on the Heim joints. So one of these mounts has to be more rigidly mounted. The top one can be a Heim joint, but the bottom one needs to be rigidly mounted. So I went to work today and just kind of whipped this up. And this is just a piece of solid rod, and just went in the machine up to the mill and just skimmed off from the sides to make it so it's the same width as the little Heim joint is. 5/8, 625.625, and then just skimmed that down and dug a 1/2-inch hole in there. And then whenever I make my lower mounts, where I make my lower mounts down here, I won't use those ones. I'll make new ones, but I'll just use a shoulder bolt, and that'll hold that. And something else that I also did, and I think this might be important, is I made this kind of have about 1.5 inches of travel. And what I'll do is I'll get a spring, a heavy spring, maybe 100 pound per inch spring with a 1-inch inside diameter, and then have like a little plate back here that's welded to this tube, and then have a plate up here that's welded to this rod, and then the spring will go in the middle of those, and it'll keep constant pressure against, keeping this open. But if I run into something, it'll give me some shock absorption and it won't break things. Yeah. All right. So I think I've certainly explained that enough. If you have any questions or whatever, just feel free to leave a comment on that. Wow, we've gone into 20 minutes and I haven't even talked about the winch yet. This winch is going to come down to roughly here. I'm not sure where yet, but this winch is going to come down to roughly here. It might pick up here, or it might pick up back here. Just depends on how long these rods are and how long that distance is and where this picks up. I'd kind of like this to pick up a little bit behind the center of gravity, the balance point for this deck. Because in any event, whether it's a 4-bar or the front is hanging, this strap is going to be holding the majority of the weight of the deck. So I made a bracket that mounts back there, and I picked up the lower points of where the motor used to be. This used to have a front motor for that mid deck. So I picked up the lower points for that, made some new points on the top, and then made this overly beefy 1/4-inch plate that holds this tight. I went ahead and overbuilt it with 1/4-inch steel because, one, I'm not terribly worried about weight, but I am worried about it being stiff and rigid, and I don't want this to bend over time. So yeah, that's that. And the way this thing works, it's a little bit weird. It's a little bit awkward for raising and lowering the deck. Fortunately, though, raising and lowering the deck isn't something that I do very often, maybe 3 times a year. So it came with this little ratchet wrench thing, and that just goes on here somehow, yeah, like that. And then you just crank it in like that, and that would be raising my deck. And then you flip the little switch here like that, and that takes the pressure off of the belt, and the deck goes down. But of course that's not any good because it would go down really fast. I say that, why doesn't it move? Oh, because this is still on it. It would go down really fast, so I think I'll have to like flip the switch, move this forward, flip the switch, ratchet this back, flip the switch, move this forward, flip the switch, ratchet this back. I'm not exactly sure, but one or the other, I'll lower the damn thing. And so that's how that's going to work, I think. And then I'll have a little bracket that comes out here, and this little rod will be underneath that, and that bracket will hold that up right here just to keep it from touching stuff. And then all the weight of the mower deck will be held by the winch, but it'll be transmitted to the frame through this and the winch. So they'll both be taking some of the brunt. What I might end up doing, if it really annoys me, and I don't even know why I'm bringing this up now, but I may end up taking this belt off. Not only do I not need 20 feet of belt, I'd also like this to be black, or at least a oranger shade of yellow so that it matches. So I may end up taking that off and stain it. That was a lot. I think I covered it all. But that's what I'm up to. I need to make those couplers to mount the blades to the motors. I need to get these motors spinning, figure out how to make those things work. And well, I just need to do everything else too. I got a bunch of parts on order. Got more of that round tubing on order. Got more of those rod ends on order. I just got all kinds of crap coming. So that is what I've been up to. Man, it's been quite a weekend. All right, thank you for watching, guys. It's a long one. We'll see you next time.